recordings are only for you guys. Please don't share with anyone, okay?
Yes, sir. Yes.
Yeah. Because these recordings are not going to be that much so formal or something. Based upon our conversations, it will be. Okay. So to open up this particular software, anything like we should know like where we are working actually, in which space that we were trying to solve all our problems, all those things and all. So for that, actually, I have created your particular folder. So that particular folder here, I'm just calling this in the documents. I would like to save your files as an NIT SAL. Okay. So I would like to install whatever it is there, like your recording videos or your Abacus files, all the things. So putting all those particular files, it is going to be a biggest messy up task for us. So inside this, I would like to create a new file. Then I can just say this Abacus solving. So this shows that like inside an Abacus solving, again, I can go one more file. And in this particular file, I can just name it as one dot. With today's date, I'm just going to keep. Okay. If tomorrow, like something like maybe after a few days, like maybe when we are meeting up for the next time, the date might be around like 18, right? So when we are meeting up on 18, it would be like 18/09/2021. Okay, like this, I'm just going to do all this particular stuff. So whatever the models I'm going to do. Suppose in this, if I'm going to do any multiple models also, I'll try to capture of all these things. Okay, but the 1, 2, like this, I'm going here, it is just because of to indicate that which one has done first and which one then as second. Okay, so you can also follow this. This is a way trend. Normally, I used to follow it to remember all the files and all. Now, today, what I'm going to do, I want to save in this particular folder. So I'll go inside this. I'll click on this. I'll copy this particular path. And now going here to the Abacus. Now file, set working directory. In set working directory, by default, it is like C and 10. But you can paste whatever you the URL that you have copied just now. You just paste it here. And now in this, you can just go here. This is how actually that you can able to paste and then you can able to visualize the things. Now it has been pasted. It has been pasted. So this is where my working directory it is there. Okay. So now whatever I do, everything is going to be saved in this particular working directory only. And the other two aspects that we have seen yesterday's class, it was like file, import, part we have seen, and model you have seen. So the things that you should remember, it is like, just like I'm just trying to, okay. I can just go it like this. So it would be helpful for you also for better understanding. So later on, if you want, today itself, you can able to do something over here. So let me go and create one presentation for you. So whatever it may be, like you can just go here. So now you can just know like how to set up your working directory, that the current working directory that you need to set. So these are the few topics that is very important, guys. So you should never lose your paths that where you are saving your files and all. So first thing that you are trying to learn is like how to set up the working directory, that you know it now. Now the other thing is like it's file, import. These are the parts of everything that you know, right? So these are things that you should. So for part, everything that whatever it is there. So those things that you should be aware about those things. So now I'm just trying to snap this. So we were just trying to keep this one. So file, import, and you can able to take up the parts also. Now, what are the types of a parts that is possible for you? What are the types of a parts that is possible for you? So file, import, part. If you can see this one, I'll just drag this a little up, and then you can see these are the file formats that it is possible for you. The best file format is called as an STP format. The best file format is called STP format. So you should always use that in STP formats. Okay. So you can also snap this and then keep it with you. Guys, so only for a few things that I'm trying to do it like this, because it's very, very important that how we are trying to bring this. I would like to put it here because we can see one more thing also. And this is where in STP files that you can see it. Okay, suppose now this is where like you are selecting of the part. That's why you can able to see this. You are using a part as your window. Okay, so other things actually we have again, sketch we have, assembly we have, the model we have. When you have a part, these are the file formats that you can able to import it. But actually, when you have a something like an import model, when you just click on this model, these are the things, something that you can able to use this one. These are the things, something that you can able to use this. Okay, these are the things, that's something that you can able to use this when you click on your model. Majority of the people get confused here and they will try to work out on that. So I'm trying to import a CAE file, but still I didn't see any option over there. Then what is the reason? So you should use this one. Okay, keep here. Okay. So this is where actually you can see this. You know how to set up a working directory. And when you go for a file import, as a part wise, what are the parts that you are importing it, and the model wise, what are the models that you are importing it. This I'm telling you, like if you have a face any difficulties, because Abacus is a software meant for analysis purpose, not for the design purpose. So you might have designed your part in any other softwares like 3D design softwares like you may use Pro Unigraphics, CATIA, or some other things like an AutoCAD files or whatever it may be. If you would like to import those particular files, then it would be helpful for you. So that's why I'm just telling you this. Now go back here. You don't have any parts, but you have a modules over here. These are the best possible modules of all available over there. These are the best possible modules of all available over here. So we need to discuss about an each and every module over here. So we need to discuss an each and every module. So what we are going to do that. So let me.
So then how will you make a section or any component of
Yeah. I'm coming that. Don't worry. So, okay. So now this is where like these are the modules available with you. These are the modules available. So using these particular modules that we are going to create our sections and all. So whatever the sections that we have it, so you can able to do those particular modules over here. Like now, this is where actually you just go here and try to at this. Okay, anyways, this is not required for us. Module name it is required. This is a part module property assembly. So on each and everything that is having its own importance, so you can write this. So in the part module, now firstly, today we are just going to see about this, all these particular operations. So by end of the day, you should be and understand that like each module will help for what exactly. That's what you should know. Okay, so now I'm just going over here. Now in the part module, I didn't have any part. So I'm trying to create my new part. So to create a new part, these are all the tools that is available. So under the module, once if you select it as a part module, then these tools that will be helpful for you to create this one. Okay, so the first thing is called as in create a part. If you just go and stay over there, then it will show you the name also. You just go and stay your mouse over there, then it shows you like a part manager. If you just go over there and create a solid extrude, it will show that. But actually to this icon, you see there is a small difference. It is a small down arrow. It is coming on this. A small down arrow. It is coming on this. Small down arrow. Again, for this, it is not there. Again, For few of them it is there and few of them it is not there, that particular small down arrow. So the small down arrow, it indicates that there are multiple tools are hiding inside that particular option. Like you just go there, try to click on this one. If you directly click on this, it will show that there is nothing all because it cannot perform that operations directly. But try to give a long click on this, try to give a long click on this, then it shows you what are all the operations inside it is available for you. Try to click, give a long click on this, and then it shows you all the informations available for you. Try to give a long click on this, then it shows you the informations. Try to give a long click on this, and then it shows you the all the informations. Okay, all the different tools available inside this particular tool channel. But here there is no other things are hidden inside this, so it's only a one thing. Whether you click, give a long click, or it's a single click, it will always take it as a single click. Okay, so now this is where first thing, as I don't have any sections over here, I don't want to import it from any other things and all. I would like to try to generate my sections over here itself, if it is a smaller sections. But if you want like it is in a quicker way that if you want to do it, like you can do the third-party softwares also, no issues, that we will try to generate your models over here. Okay, so I'm just trying to click on this, like create a part over there. Now after creating this particular part, so I would like to name these particular parts also. So I can just say this is my I section. Let's say this is my I section, like if I want to create it. Now after creating, when you are trying to create this particular part, it is asking you a few parameters like modeling space. That is whether you want to model it as a 3D or you want to model it as a 2D or it is an axisymmetric condition. Okay, so you should remember these three particular parameters. It's a 3D, 2D, or an axisymmetry that you are trying to do it. So you can choose this one. If it is a 3D, that is nothing but in general, whatever the object it is there, that we are going to do it. If it is a 2D, we are making an assumptions to bring down that particular 3D part to a 2D part. This is where that you might have learned about plane stress models, plane strain models. Okay, so extracting the mid surface, those are all the things that is available for us in 2D planar. And this is an axisymmetric model that which about an axis that when we are trying to revolve something, then this is called as an axisymmetric model. So in all your problems, we need only a 3D. So I'm just selecting as a 3D over here. After going in detail, if something is required, again, we will come back to this part session and then I'll explain you about those things also. Okay. So now let's, for the time being, let's assume that we are trying to do it in 3D. So click on this 3D and then go for the type actually. So in the type, that which type that you are trying to do it, either it's a deformable one, the object of a name I section, which you are doing it in 3D, and that what is the behavior of it, that you want to make it as a deformable one, or you want to make it as a rigid one, or you want to make it as a Eulerian one. So Eulerian is not required for you guys because this talks about your fluid. So fluid is nowhere involved in any one of our projects. So I'm not talking about this Eulerian. So we are talking about this deformation or rigid body. So I feel like in both of your projects also the rigid body is not necessary, but still I would like to teach you that because it's a quite commonly used one. So rigid body, the name itself is, we know that rigid body means that it doesn't have any kind of a deformations or no stresses involved in it. Okay, so it's just an object lying in our analysis, but it will never participate in our analysis. It's just an object lying over there, but no results, contributions, or nothing, no contribution from it, and during the type of an analysis. Okay, again, these kind of a rigid bodies is always like a fiction body something. In reality, there is no real rigid body. Rigid body is the one that is a fiction body that we are assuming it for our analysis. Okay. In what cases I need to consider a rigid body? So when you say like I'm working on some 20 components or 15 components, out of that like 3 components, which is very far from my functionality, but still I want to place the particular components, but I don't want to see what's the behavior on those particular components. In that particular cases, which you want them to be present in the model, but you don't want to see what's happening to that particular model. In that particular time, to save a time calculation time, then automatically you can use this particular them as a rigid body. So there again, there are like a 2 different types of rigid bodies. One is a discrete rigid body and the other one is an analytical rigid body. So discrete rigid body can be helpful for any kind of a complex structures, and analytical rigid body can be done only for a very simple structures, which is like planar in conditions. Okay. And analytical rigid body doesn't require any kind of a mesh, but discrete rigid body requires a mesh to be generated on it. Okay. So now the type, I have decided it. It's a modeling space of 3D, and I want to make this as a deformable, because when I'm trying to apply some force on it, it should deform it. It should deform it. So that's why I'm choosing this as a deformable one. And then base feature of it. Inside that particular deformable one, what is the shape that you want? For that particular shape, what is the type that you are trying to do this? Okay. What is the shape that you are trying to model this particular 3D in terms of like a solid one, or in terms of like a shell one, or in terms of like a wire, or in terms of like a point? Wire is nothing but like a 1D element. Shell is nothing but your 2D elements. Okay, I'm modeling, representing the space as a 3D only, but still I can model that as like a solid or a shell or a wire or a point. So these are the features available for you. So as of now, to the point I have seen it. So first we will try to work out only on the solid. In future, if I required, I will come to your shell and wire also. I will teach you on this. Now going for the shape, solid. Now inside the solids, like if I click on the shell, my options are changing. See this, it's a planar, extrusion, revolution, and sweep. If I click on my wire, it's a planar, it's showing. If I click on my point, it's a coordinates, it's showing. Okay, if I click on my solid, the possible types here I can do is called as an extrusion, revolution, and sweep. So what is an extrusion? So in the name, actually, like if you see there are, we can see it's an extruded bar, actually it is, or an extruded aluminum channel, we can say. That means there is a kind of a profile that we have. There is such kind of a profile. Let's say like we have this kind of a profile actually. So let's say that we have this particular kind of a profile, and the same profile, I would like to extend this. I would like to extend this for over a length actually. I would like to extend this over a length. The same amount of a profile that I would like to extrude this over a length actually. So this, so when I just want to do this one, so same thing, that all we can do it in our software also. That is what you have an extrude definitely showing this. So the same profile, I can able to extrude it to 1 over length actually, length of it. So that is what actually the extrude is showing. Now we will see first extrude, and then we will come back to the revolution and sweeps actually. Revolution is also not required in to the Asish project as of now I have seen. If others also, if you can share me your project papers at least, then I can able to support you on the things. That's why I'm asking you to please give me the papers before starting out the session. So, okay, anyways, like we are going for extrusion here, solid extrusion. And now, before clicking on continue, here we can see one more thing that's called as an approximate size. Here we have seen that's called as an approximate size. What is that approximate size? Okay, so the approximate size, it indicates that your graphical user area, how much amount of an area that I want it to be visualized to do this particular task, to do this particular design, how much amount of an area that I would like to do this one. So for that, actually, we require this particular size of this. Okay. Now we have seen all those things all the way, like we are planning to design some kind of a model, and we are first time that we talk about a numerical number that's called as a 200. And they were clearly saying it is a size. What is this 200 meters or 200 mm or 200 centimeters or 200 kilometers? What actually this 200 it indicates? Okay, so please be remember this, guys. Abaqus default doesn't have any units on its own. Abaqus default, it doesn't have any units on its own. So if you just type, go to the Google and type it as like an Abaqus units and go to your images here. So it shows you like a display the unit systems that Abaqus follow actually. It shows all the unit systems that an abacus follow. If you want like something kind like an images wise that you can use this one, you can use this particular things. So the best one is this one. Okay, so you can try to capture this. It shows your clear information here. It states that this particular image, if you just go and see this, if you just see these particular things here, that Abacus doesn't have a built-in unit systems. So Abacus, there is no built-in unit systems. User must use a consistency in units. Suppose if you are doing your length in meters, then force you have to apply in newtons, mass you have to derive in kgs, time you have to go in seconds, stress you have to define in pascals, energy is in joules, and density is in kg per cubic meter. Suppose if you are going at an then these are the things that you should follow. If you are going in a feet, you should follow this. If you are going in an inch, you should follow for this particular thing. So the moment that when you are trying to pick this particular 200, you should decide yourself that you are going in a meters or a or a kilometers or whatever it is. So here, all our papers are also represented here in meters. Many of the cases, if we go in millimeters only, so not in meters, it's in millimeters. We go in millimeters. So I'm considering this as 200 millimeters and then continue. Once I click on this continue button over there, here I can see this. To zoom in and zoom out the things, you just use your middle mouse button. You just use your middle mouse button. This is where it helps you to zoom in and zoom out the things. It helps you to zoom in and zoom out the things. Joystick key, the scroller key on your mouse, you can able to move it, scroll it. So automatically you can see this. This is will zoom in and zoom out. Now the value that we have entered at 200, it is there, right? This is 200 by 200. 200 by 200, it is going to come. So equal number of boxes, all the faces. And this is your center. This is your center point for this. Okay. So this is what actually the 200 by 200 length that we have selected it. So if you says that, so I can't go like 210 mm in my design. You can go, but the graphical representations, like the graph visualization, you can see up to only 200 mm. Suppose if I change that value to instead of 200 mm to some other values, then automatically you can do that. But you have to do it while creating the part itself. You have to do this while creating the part itself. Let's say, yeah, I'm just coming here. We will see that how to edit those particular values also. Okay, so yeah, I'm not selected anything. This is where like you can scroll in and scroll out. Like if you would like to pan it, like you want to move your graph and all, like a little up and little down, then use your control button. Sorry guys. Just give me a second, guys. Just give me. Okay, I'm sorry for this call, guys. Suppose like whenever you just want to do this rotation options and all, that you can able to rotate this. You can able to rotate all your things. And whenever you just want to fit this particular things, you can able to fit it over here also. This is where like a fit options that you can able to do this one. So you can able to fit this particular all the things around. So, and if you want to get back to your normal positions, you would like to get back to your normal positions, then you can use this particular option tool here. Here you have this particular tool. This tool, we call it as a views actually. You just click on XY plane. then you are back into your XY plane. Suppose if you want to generate your model in a not an XY plane, you want to generate your model in a ZX plane. So now this is where actually, because we are trying to do any kind of a model in XY plane, and then in the third directions that we were traveling. So you can able to do this one. You can zoom in, like you can click here, you can zoom in and zoom out wherever you want it. You can go pan also in the same way that you can able to do. Suppose if by mistake, you have to hold your control and hold alt button also. Both you have to hold control and as well as the alt. And then when you are trying to rotate this particular model, when you are holding this alt and control, and when you are trying to rotate this particular model, during this particular rotation, suppose if you lose control, then you have to come back and click it over here, like and apply on the front view. So then automatically it will come back to your front view. Guys, if this meeting ends in 10 minutes, please try to join back on the same link. Okay. So now I would like to create one rough section or rough part that I would like to do. So before getting into this, the very important parameter that you should know is like controlling degrees of freedom. So try to search out for a definition called what is degrees of freedom. DOF. What is degrees of freedom? So this is a homework for you. Mostly in the next class, I will ask you what is the degrees of freedom. Okay, so I need this. What is degrees of freedom? Let me go and save this so that I can share you this particular presentations with you. Okay, so now going here, I would like to do this one. So these are all the sketch modules actually. Previously in the part module that you have seen a sketch module also, right? So the sketch module is nothing but like inside the part module, when you select it as a create a part, then automatically you are entering into your sketch module. Now in the sketch module that you can able to generate this one. So for generating this one, first thing is like I should know like how to arrest all my degrees of freedom on this. So once if you arrest all your degrees of freedom, then it shows that your model is in a green color. If it is not in a green color, then it shows you are always in a white color. So example, I'll show you that. So before that, this is your center, it is indicating it, but somehow I just need to fix it my center again. So for that particular things, you know, like whenever there is a down arrow, you should give a long click on this, then automatically all the other options it is going to come. So this, I'm just selecting it as a horizontal line. Create a horizontal line. And the center point for this is this point, I'm just selecting it. So now you can see this, it's a horizontal line, it is showing it. And once if you would like to escape this one, click on escape button, then the particular option will escape automatically. Now, if you see this horizontal line, it is showing in a green color. So now similarly, I would like to plot on a vertical line also. So again, you have in this option. So long click on this and create this of vertical line through. So select this particular vertical line through, and then you can click it over here. So now you have one horizontal line and one vertical line. You have one horizontal line and one vertical line. So these two are like basic things. And if you clearly observe it, it's like a light green in color. So those are like fully constraints. Okay. Now I've based on this is my center. So now I can call this as my origin position of a 0 and 0. And from there, that whatever I wanted, I can able to do all those particular things. So let's say from here, I would like to generate one small rectangle, like create a rectangle with the 4 lines. Okay, so I'm just selecting it. So this arrow is indicating this. You want one start point and you need one end point. These 2 points are more than sufficient to create this one. So once if you pick this particular rectangle, here it shows you like pick a starting corner for the rectangle or enter X and Y coordinates. Like if you can enter this, you have to enter with the same X comma Y. So the same syntax that you have to. So 0 and 0, I've just entered it. Now it is asking you that pick the opposite corner for the rectangle or enter that X and Y Z values. So in X direction, I would like to go for 10 mm. Let's say in X direction, I would like to go for a 10 mm. And in Y direction, I would like to go for another 10 mm. So you can just give OK. Now see this one. automatically it has been created. Why I'm explaining you with these options is like you might have been familiar with your AutoCAD operations. So it would be often easy for you to do these particular tasks. So it would be easy for you to do these particular tasks. Okay. And now actually you have done this particular things. It is like you have created a sketches. Suppose if you want to come back, you just put it as Control Z, then you can automatically it will leave that. So again, you can go here. So whatever you can choose point here, or you can drag and you can choose another point here also. And now, before I know it was like a 10 by 10 rectangle. I'm just creating it, or a perfect square. I'm creating it. Now, how to do this particular thing? So how to measure this particular dimensions over here? So now I would like to measure the dimensions also. So to measure the dimensions, we have an option here called as an add dimension. To measure the dimensions, that we have an option called as an add dimension. So click on this add dimensions and choose this particular points. Now, if you can see this, guys, this is not a perfect in something green or something like that. But when I'm trying to measure the value, see this point to this point. So the value horizontally, it is 50 mm. It is saying that, okay, I can go with 50, enter the value. Now, similarly, from this point to this point, vertically, it is 30. So I can just go ahead as the 30, or if I want to make it as something like 45, you can just make it, or if it is only a 25, you can just go it as 25. Okay, now see this one. It is all moving from 25 and 55. Everything is done. Now you can see this. It's almost into a green color, that which is a fully constrained model. Now all the dimensions it is done. Now sketch the selections for the solid extrusion. So just give done. After giving done, extrusion is nothing but that what we have discussed is like on the third direction, so how much depth I would like to travel for this. So now here, depth wise, how much mm that you want to go, how much mm that I want to go. So the depth wise, let's say consider that initially I'm just would like to go around like only 10 mm. Or assume that it's just a 10 mm that I'm just trying to go it. Just give OK. Then automatically your solid it has been generated. Sometimes actually you may see this particular solids and you would like to rotate this particular model. Use Control and Alt button. Press both the buttons and use your mouse button 1 to rotate your model. And use Control and Alt and use middle mouse button to pan it. Or use Control and middle mouse button and use your mouse button 3 to zoom in and zoom out, or directly using simple joystick key also you can able to use for zoom in and zoom out. Okay, this is how you can able to rotate this one. You can able to rotate it. Sometimes the model that you can see is always like in isometric view that you can see this particular thing. So it's not perfect. So to make sure that my model should be on always visible, turn on perspective view. Now it's on a perspective view point of time. I can see this, but when I just click on this, turn perspective view off, then you can see that the model is in perfect directions. So the model in a perfect directions that you can see this. The model in a perfect directions that you can see. Okay, so you can see this model into your perfect things. Now I have generated this particular model. Now on this, I would like to create a one more pattern. Actually, on this, I would like to create a one more pattern. Now actually what you can do is like, I would like to do this particular things. On this, I would like to extend this particular things and all. Or this is where like an I section top plate that I can show. I can rename this also. I can rename this. That's an I section underscore top plate. I section underscore top plate. I can see it. Later on, if I want, I can go on with like a different names also, as whatever the way I want it. Now I can use this create a solid extrude option. It is there. So now click on this one. Now click on this create a solid extrude. Now it is asking you to select a plane for a solid extrusion. So I would like to select on this particular plane. Now it is asking you select an edge or an axis that will appear it. So about this particular axis that I would like to extrude this one. Now on this again, you can go and start building your horizontal and vertical things. Please habituate it this guys, as you are very beginners. Please habituate this. Otherwise, if you are confident enough of doing this stuff, then it's not required at all. So how to control the dimensions that you should know.